Hello and welcome to Talking Steam, a podcast series by Spirax Sarco. We are the world's leaders in steam technology, offering the industry's most extensive range of products and services across a variety of industries. We create solutions that set the benchmark for steam-using organizations worldwide, working with you to improve productivity, save energy, and reduce waste.
Welcome to the Talking Steam podcast. In this episode, I'm joined by Ricardo Murakami, Technical Manager from Santiago, Chile, where we will be discussing a flash steam recovery project that Ricardo and his team were able to deliver for a local brewery and soft drinks manufacturer. Our conversation will include topics mentioned in previous episodes of this podcast. So if you haven't already, I urge you to go back and give them a listen. In the last episode, we spoke with Michael Stamm from Germany, who talked us through the methods for differentiating between controllable and unavoidable losses and how to ensure that the energy and water you are recovering is from a flash steam plume rather than from possible leaks within the steam system. We also discussed the need to identify an adequate heatsink to hand over the energy to and ensure the fastest possible return on investment for this type of project. Ricardo Murakami is a mechanical engineer with a master's degree in industrial processes. He has been working for Spirax Sarco since 2005. Ricardo is an experienced project and applications engineer who is currently responsible for Spirax Sarco's service and engineering teams in Chile and Peru, who are focusing on supporting steam users to maximise the efficiency of their plant and process. I'm Mike Skidmore, your host for the Talking Steam podcast, where in this series we are focusing on heat recovery opportunities at food and drink manufacturing sites. Just a quick note to say that due to the COVID pandemic, this interview was held virtually rather than face-to-face. Hey Ricardo, thank you ever so much for joining me today and welcome to our podcast.
Hi Michael, thank you for the invitation and good to talk to you.
My pleasure. Ricardo, for the benefit of our audience, can you please describe to me where you are talking to us from?
Yeah, for sure. So I'm talking now from Santiago, Chile, and this is where I'm currently living. And my team is based on Santiago, Chile and Lima, Peru, so this is the support I have to support both countries.
Fantastic. So quite a wide spread there in South America. So throughout this podcast series, we have learned from other guests why steam plumes at a food or drink manufacturing site exist, and then also what can be achieved through taking action to reduce them, and also the considerations that need to be made to make sure that we achieve the highest performance from a flash steam recovery system. And Ricardo, today you're going to talk us through your experiences from putting these measures and these actions and steps into action when you worked with a manufacturer to reduce their visible emissions and save energy and water from their steam plumes. So to kick us off, can you please give us an understanding of the manufacturer in this instance that you worked with and the problem that you were addressing?
In this specific case, we're going to talk about some initiatives we've been taking in a beverage facility, which produces mostly beer, water, and soft drinks. So in this type of manufacture, steam is a very important resource for them because it represents a great part of all energy consumed for production. For example, I've been told that in some manufacturers, more than 50% of all energy consumed comes from steam. So in this kind of customers also has a pressure to reduce costs. So that's why we were called to find some energy saving opportunities in the steam system. In this case, factors like this has process related to the production of beverage and also the packaging in various formats. So, for example, bottles, cans, etc.
Right, okay. And in that case, then we can assume that will be processes including the production, such as pasteurization, all the way through to packaging, which would be similar to sterilization of the bottles and the cans themselves as well.
That's perfect. So we're talking about pasteurization, also bottle washing, and some secondary process.
Okay, I understand. And Ricardo, from your team, you and your team's point of view, what steps did you take at that very front end to understand the controllable and the unavoidable losses contained within that customer's steam plume? And in this case, when we refer to controllable losses, we're talking about the losses that could come from failed steam traps or leaks in the plant and are controllable through maintenance operations. And then the unavoidable losses being the presence of flash steam, which, as we know from previous episodes, comes about due to the pressure change of condensate moving from an area of high pressure to low pressure and the reboiling effect there happening.
Yeah, well, it's very important to differentiate between those two kind of losses. For us, as part of our service portfolio, every time we perform a steam system audit, the first step we do is to perform a kind of trap survey to the site. So it doesn't mean we are looking only for the trap, although trap is the most important part, but we are also focused on finding some live steam leakage to the condensate return line. So that's why we address, let's say, the controllable losses. And then second step is the understanding of the main process and the process that can generate the flash steam to the condensate line. So this is where we find the, let's say, the unavoidable losses. So this way, separating the controllable losses and uncontrollable losses, we can find the better solution to address each problem.
Perfect. So in this case, which processes and equipment was it that the customer was using that were generating that flash steam, those unavoidable losses?
Okay. Well, firstly, it's important to mention that flash steam can be generated virtually by any process that uses steam trap. This is because steam traps requires discharging from higher pressure zones to low pressure zones, and this is the same principle that generates flash steams. But in this specific case, during the audit, we found some main equipments that could generate more flash steam. The first one is the process water heating, which is heated by steam. And process water is one of the most important ingredients of the beer, so there is a high amounts of volumes and energy in this process. And the second process was the wort kettle, which is one of the main, if not the main, steam consumer in this area. Luckily, in this factory, both condensates were directed to the same atmospheric tank, so we can saw flash steam leaving from the same place.
Wow, okay, so that's two quite considerable, quite large processes, which would be generating, I imagine, a lot of flash steam, both going back to the same point. So it must have been quite a visible plume of flash steam coming out of the vent from that unit. Were you able to quantify the amount of flash steam that was generated?
Yes, I mean, this is a very important part of our steam system audit. But as we were in the site and we collect some data, and also based on our experience in this kind of factory, we could calculate and estimate the amount of flash steam that was being vented.
Fantastic. So by doing that, it meant that you were able to, I imagine, calculate the kilowatt of energy contained, heat energy contained within that plume, and then also translate that to a potential CO2 saving and also monetary saving there from the energy and the water.
That's perfect. So when you talk about flash steam is almost energetically almost the same of live steam. The difference is it doesn't cost anything and also doesn't generate CO2 emissions.
Perfect. But of course, to be able to realize those savings that you're looking to recovering flash steam, you actually have to be able to put it somewhere. So I guess when we look at how we then implement a flash steam recovery system, what we've got to start to understand is the logistics of where parts of plant are located on site, and also where that energy can be put into. So, Ricardo, in the case of this manufacturer, where was the flash steam plume actually located on their plant?
Yeah, in this case, the condensate tank was located very close to the process, so not in the boiler house, not outside the factory. So it was good because it was very close to the potential heat sinks, but also as a closed room, every steam plume was located above the roof. So for the operators, there was no visible plume, although the losses were there.
Okay, I understand. So, but when you say a visible plume, that means no visible plume for the guys actually working directly next to the equipment undercover. But I'm sure if you were to take a step away from the factory and look at it from, say, the car park or the entrance, there will be quite a noticeable plume being emitted from the roof.
That's correct.
Okay, I understand. So, Ricardo, considering that this plume had been identified and you knew how much energy was available, what did the solution look like when you went to recover that flash steam?
Well, in this case, the main purpose was to recover the flash steam, of course, but we were concerned about causing some back pressure to the condensate return, and so the main equipments. This is mainly because some equipment in this kind of manufacturers are very precise in their temperature control. So any back pressure could cause, let's say, problems to the production. So the main solution, or the conceptual solution, needed to think on these two sides. And for us, the best solution in this kind of process was to install a vent condenser, which is an equipment that can save flash steam and save its energy, and also work without the need of pressures or generating back pressures to the steam system.
Fantastic. So when we talk about generating or creating a back pressure on the system using the solution that we're implementing, what we mean by that is by raising the pressure behind the steam trap, you are reducing the amount of condensate that can be passed through the steam trap, and then also limiting the amount of heat transfer that can occur at the process. The consequence of this, obviously, is that we end up reducing the amount of product that can be processed, or achieving the correct temperature for the amount of product that is being passed through. So both of those being negative symptoms, being negative outcomes. So in this case, the way Ricardo described there, the atmospheric vent condenser means that you can achieve zero back pressure, but at the same time recover all of the energy and all of the water from that flash steam. So, Ricardo, you spoke about the heat sink there being quite close to the tank as well. And can you tell us a little bit more about that heat sink, please?
Water is a very important ingredient for the beer, and this requires heating for the process. So for us, this was a perfect heat sink for the solution, as it was close to the condensate tank and required a large amount of energy. So basically, the solution was to transfer the flash steam energy to the water, and then reducing the requirements of live steam in this equipment.
Okay, and how about the synchronization of the process and the heat sink that you were using as well? Did you have any challenges with that? Were you able to use the flash steam as it was generated? Or did you have to introduce any kind of buffer system to store the energy to be used later on?
Well, luckily in this site, there was a hot water tank. So it worked as a energy storage or a buffer for the process. So no need for major equipment to synchronize both processes.
Fantastic. So a relatively easy implementation there, and what sounds like a relatively simple solution as well. Ricardo, I mean, of course, by calling it simple, I may be dressing it down a little bit there, but were there any challenges that you encountered when implementing that solution?
Well, I think we can say it's a simple solution right now because all the experience we have gained in other customers, in other kind of manufacturers. So I would say from the technical point of view, it was a very simple solution as we already have a good technical background in this kind of equipment, and also in the way we specify these components. Probably the main challenge in this kind of manufacturer was to deal with the 24/7 operation that they had. So this gave us a few windows to install and to commission everything and to make everything ready for the startup. One of the points that helped us in this case is every kind of engineering support we provided to the manufacturer since the beginning. So we were able to address relevant issues that could appear even before they appeared.
That's great to hear. So preparation and previous experience and technical expertise meant that the solution was delivered correctly. So fantastic. And I guess the final summation of this story, the final result, what was the result in this case for the manufacturer? Did you achieve the result that they were looking for?
Yes, the main point of the whole project was to reduce energy consumption. And as we said before, steam is a very important energy source for them. So at the end, after all implementations, we saw that we were able to reduce around 2 to 3% of the total steam consumption of the plant.
Wow, that's quite a significant amount, isn't it? Especially when, if we go back to your statement earlier of some manufacturers where steam makes up 50% of their total energy usage of the complete plant, saving 2 to 3% of that can really start to add up to serious, not only monetary savings in the fuel, but also CO2 savings associated with burning those fuels, and especially when it's fossil fuel. What was the impact as well, Ricardo, on the visible plume that was coming from the site? Did you see a reduction in that?
Yes, I mean, the factory works as a closed room, so there were no visible plume inside the factory that could, let's say, damage or cause any injuries to the operators. But if you go outside the factory, let's say the other side of the road, you could see some sort of steam plumes coming from the roof. And solutions like this were able to reduce this visible plume.
Brilliant. So another outcome for this manufacturer, which no doubt was positive and hopefully helped improve their neighbours' opinion of them as well. Thanks ever so much for sharing that story with us, the project that you implemented at that site to recover the flash steam for that brewing manufacturer and soft drink manufacturer. And one thing I think that everybody listening to this podcast would like to know from you is, and as a final question, is what would be your advice for any food or drink manufacturer who is looking to reduce the visible plumes at their site?
Firstly, it's important to remember that flash steam is as good as live steam from the energy point of view. So every time you see a steam plume being lost in the atmosphere, it can represent a potential saving on energy and money. Reducing steam plumes is an ongoing job, as it involves action from the operation and maintenance. For example, making sure traps are working properly, there is no live steam leaking to the condensate return lines. But it's also important to keep an eye on the technologies that are coming and can give you some sort of extra efficiency in the steam systems. So if you're bothered about any steam plume, or if you see that plumes are increasing in the factory, my final advice is to contact an steam expert so they can address your concerns properly.
Thanks, Ricardo. Thanks ever so much for that insight there, and also for sharing your experience with us. It's been a really great way to add some practical context to the discussions and the learnings that we've had from the previous podcast episodes and apply them into a real life example there. It's been a pleasure talking to you. Thank you ever so much, and I hope you can join me again in a future episode.
For sure. Thank you, Mike.
That was Ricardo Murakami, sharing his story of working with the brewing and soft drink manufacturer to reduce their visible plume and save energy and water. As Ricardo mentioned, this manufacturer had multiple high-demand steam-using processes which were contributing to creating a significant flash steam plume that was visible from outside the plant. By starting out with a steam trap survey, they were able to identify and separate the controllable steam losses from the plume. This ensured that there was not an excess waste of energy and water through live steam escaping to atmosphere, and it guaranteed that this type of heat recovery project delivered a consistent return on investment into the future. They were then able to use an exhaust vapour condenser to capture the heat energy within the unavoidable flash steam plume and use it to preheat water being used as hot liquor in the front end of the process. Ricardo discussed overall plant energy savings of 2 to 3% for this project. And while these figures sound modest, these savings can translate to many tens of thousands of dollars when considering the typical fuel spend of a medium to large food and beverage production facility. Join me in the next episode where we will be summarising everything discussed in the past 5 episodes and setting out a plan of action for a food and beverage manufacturer wishing to reduce their visible steam plumes. Thank you for listening, and I hope you continue to join us on this series of Talking Steam.
Thanks for listening. We hope that you enjoyed this podcast and join us again soon. If you have any questions about the content covered in this podcast, please reach out to us or your local Spirax Sarco engineer. Watch out for future episodes coming online soon. Follow Spirax Sarco on LinkedIn and listen to get updates on new episodes.